First thing I ask myself when I'm looking at a sine graph, I'm trying to decide, well, what's the midline? I mean, is this graph being shifted up or down? And on this graph, I'm seeing that the amplitude, how high it's coming above the x-axis here, is 4, and coming down from the x-axis is 4. So that tells me this has not been shifted up or down. So, and the other thing I know now is the amplitude is 4. So that tells me the midline is right here on the x-axis. It's not shifted up or down. And then I'm trying to look for some lattice points where the graph crosses one of the coordinates, one of the nice grid lines. And what I'm seeing is here at -1, or at 4, or at -6, or at -11. And so this tells me, and I know normally sine starts at 0, 0 at the origin, unless it's been shifted up or down. But it's starting at the intersection of the y-axis and the midline. And in this case, it's been shifted left 1. So what I'm seeing, and because this point here is not at a nice lattice point, now granted it probably is at 1/2, at 1.5 or -3.5, but because it crosses right there at that nice lattice point, -1, I want to use a sine function. So I think so far I've got sine, 4 sine, and there's some period change most likely, so I'm going to leave a space there. And I know this graph has been shifted left 1, so I'm going to write it as +1. I know there's no up-down shift, so I don't have to write anything after it. So now I got to figure out the period. And so then I'm seeing, well, it went from -11 until -1. Well, that's 10. It's 10 wide. So the period of this sine graph is 10 wide. And I know normally the period of a sine graph is 2 pi. So to find that b number of your equation, remember it's 2 pi over the period. So that reduces to pi over 5. So that's going to be my b in my equation. And now I should probably graph this to check. I'm not going to in this video, but you would set your window, use the same windows as here in the graph, same the x min, y min, x max, y max as in the graph, and then try that function. Make sure you're in radian mode. Desmos will automatically go to radian mode. Okay, so that's my process here. If you take a look at this number 18 in the book, I won't do the whole thing because this is something somebody could do for some attendance points. But again, look at the midline. I'm seeing the midline, it's going up 3 and down 3 around the x-axis, so that tells me the midline is the x-axis, so no up-down shift. I'm seeing it crosses at the midline right there again, so I'm hoping to see how that's very close to the same graph as before. So it's just a sine. I would use a sine function, shifted left 1. Then the period, well, it's going from -7 to +1, so that's a change of 6. So we could also do that here. Now, if I did go with this, suppose I went with, let's do this. This one's a little weird. So let's do this. Actually, it's the same, but it could be done differently. I see the lattice point there. I see a negative sign if I use that point there, and that would be an acceptable answer. So if I were going to do this trig graph starting there, I would say, so I see an amplitude of 3. I see a sine function. I see the period is 6, so 2 pi over 6 would be pi over 3. It's been shifted left 4, so +4, and it's not shifted up or down. Oh, but then because it starts, instead of starting at that point there and going up, it's starting at that point and going down, I'm going to put a negative in front of the amplitude, and that would be a reflected sine graph. Now, if you graph this versus another sine graph you got off this equation, you'd see they'd be exactly the same. So there's many answers. You just kind of got to decide where you're going to start. Okay? This is number 19 off that same page, and I just wanted to point out a little bit of a difference here. Well, do you see how that point, I mean, the amplitude is 1, -1. I mean, it goes up 1, goes down 1. So I know the amplitude is 1, so that's no change. But do I use a sine or a cosine? Well, unlike the last couple of graphs we looked at, you see how that point doesn't cross at a nice lattice point? But that does, that peak and valley does. So I'm thinking this is a cosine graph, and it would be best modeled with a cosine graph. We'll do both just so you can see, but I'm thinking a cosine graph is the smarter way to go. And I see instead of starting on the y-axis, it's starting shifted left too. So what I would write is, let's see, the amplitude's 1, so we don't need a number there. Cosine of, leave a space for the period, for the B number, so x plus 2, and it's not shifted up or down, but then the period is, well, I mean, you can use that distance, but I think it's easier to use the peaks or the valleys. So it's going from -7 to +3 is a distance of 10. So I could say 2 pi, because that's the normal cosine period, over 10 is pi over 5. And it's not, the amplitude's 1, so we're good. So that's one answer. Suppose somebody wanted to use a sine graph. Well, the trick with that is that you got to be pretty confident in what value is right there. I think it's probably pretty safe to say -4.5. So the amplitude is still 1. The period is still pi over 5. I mean, the B number is still pi over 5, but it's been shifted left 4.5. So you could graph, I bet you could graph both these equations, and unless we've got this point wrong, you'd see that we'll only see one graph. So I hope that helps. Check out those other couple of videos I posted.